Good afternoon, students. Today, I am going to cover a few important topics on mobile communication, such as I would like to give you an overview of AMPS, PCS, pagers, multiple access schemes, and GPRS. To start with, Advanced Mobile Phone Service, which is also termed as AMPS, this is, released in the year of 1983. And if you can remember the previous class of mobile radio communication, then you can remember that we have seen the particular frequency band for this AMPS if we can remember the initial slides of the mobile radio communication class. And what we have seen over there, we have seen that this particular AMPS uses the 800 megahertz to 900 megahertz frequency band. And for each channel, this bandwidth of this particular AMPS system is about 30 kilohertz. This is a fully automated mobile phone service, and it is the first, standardized cellular service in the whole world. And obviously, now we can say that this is the most widely used standard for any cellular communications. Why this AMPS has become so popular? Because it is primarily designed for use in cities. Later, it is expanded for rural areas as well. But what happens that whenever we are using this AMPS, we can maximize the cellular concept of frequency reuse by reducing radio power output. So this handset, has also some familiar telephone style user interface. That is why it is very much, easy to handle, and it is also compatible with any AMPS base station. So all these, features makes the mobility between service providers, that is the roaming, simpler for any subscribers. That is why it has been very much popular, after its release. Some kind of limitations still associated with the AMPS, although it has gained an ample amount of popularity. Those limitations are usually, low calling capacity, limited spectrum, there is no room for spectrum growth. Sometimes, users experience poor data communications. It has a very minimal privacy. So that is why, fraud protection is also found inadequate. For this reason, a kind of its variance, I can say, which is called narrowband analog mobile phone service, or we can term it as NAMPS, has been come into the picture. This is the second generation of analog cellular systems. So it is basically designed to solve the problem of low calling capacity, which we can face while we deal with AMPS. So it is introduced, as an interim solution to capacity problems. So now operational in 35 US and overseas markets as well. So it has been also very much popular in terms of dealing with the problems which we had previously. And it can, combine existing voice processing with digital signaling. So the capacity of today's AMPS systems have become tripled. Now this particular concept, uses frequency division to get 3 channels in the AMPS 30 kilohertz single channel bandwidth. So it is also a great advantage with respect to the existing AMPS system. So for this reason, we can see that the possibility of inference increases because obviously the channel bandwidth is getting reduced. After this, one another communication service has come into the picture of this mobile communication era, which is called personal communication service, or in short PCS. This particular service, is very much similar to our cellular telephone. So that means it provides a mobile user with voice, data, and multimedia at any place, at any time, and at any format. In case of PCS, we can see that whatever be the frequency spectrum, the operator's authorized frequency block contains, a definite number of channels. This is a fixed one. So the frequency plan assigns those specific channels to specific cells. So it can follow that frequency reuse pattern as well, which restarts with each nth cell. So it is a kind of, advantage of PCS. And we can see that whenever this kind of, frequency reuse process is going on, the uplink and downlink bands are paired mirror image. So if we can look at this particular picture, we can see that this is a kind of, system where both wired and wireless networks are integrated for establishing, a good communication. We have our very own PSTN, that means public switch telephone network. We have our MSCs. Base station is obviously connected with this MSCs. And there is a one mobile station. This is one radio network. And you can see that this MSC is having connection with the base station controller, the mobility database, and also the base station. And some kind of, frequency reuse technique is being followed for each cell. So this is what about PCS. So if you conclude PCS in its key features, then what we can say is that obviously PCS has a good architecture. PCS is a very similar kind of, technique as we can experience in our cellular telephony. So it can use, AMPS, it can use DAMPS, it can use, GSM, it can use TDMA, which is the IS95, which is our, another topic of coverage for today's class. And also, PCS handles some kind of, mobility management where we can experience handoff as well as roaming. So automatically, based on handoff, again, we can deal with the types of handoff, and obviously we can detect the handoff. And for roaming, we can register those roaming numbers or roaming users, and obviously we can deliver a call to the roaming customers. After that, now coming to the third topic, which is the multiple access schemes. As we can see that here we have three kind of access schemes. One is called frequency division multiple access. In short, we know, or we often term it as FDMA. The second one is time division multiple access, which is often called as TDMA. Third one is code division multiple access, which is often termed as, CDM. Now, what happens that these are the three strongest schemes, but it has three different, layout. means whenever we have one subscriber who enters another cell, a unique frequency, is assigned to him. So it is a kind of system which is used in analog system. So this is what FDMA is all about. This situation or this scenario is getting better while we are shifting from FDMA to TDMA, where we can see that each subscriber, is assigned a time slot so that it can send or receive a data burst. And we can, often see this kind of phenomenon in digital systems. A different kind of multiple access scheme, which is the code division multiple access scheme, can be seen where each subscriber is assigned a code. And that particular code or that specific code, is used to multiply the signal which is sent or received by the subscriber. So here we are going to discuss what are the key features, how does any particular scheme work, and what are the advantages as well as limitations of a particular scheme. Starting with FDMA, what we can see is this is a specific frequency band which is given to one person, and automatically it will receive by identifying each of the frequency band on the receiving end as well. So in that process, some bands are used which is called guard bands, and those bands are incorporated between the adjacent signal spectra so that we can minimize the crosstalk between the channels. Since it allows multiple users to send data through a single communication channels, so obviously FDMA has to divide bandwidth of the channel into separate non-overlapping frequency subchannels so that it can allocate each subchannel to a separate user, and we can minimize the crosstalk in such manner. All these channels, can be a coaxial cable or microwave beam for FDMA operation. Now, based on this process, what are the different advantages we can expect from FDMA? It obviously reduces bitrate information. It uses efficiently numerical codes so that the capacity has to be increased. It can reduce cost. So it can also lower the inter-symbol interference, which is ISI. In case of FDMA, it is not at all necessary to equalize all the signals and all the channels as well. It is easy to implement so that whenever a system can be configured, then in terms of speech encoder or a bit rate reduction, all those improvements may be easily incorporated into the system. FDMA can use a very less number of bits so that we can expect a very lesser number of bit requirement for synchronization and framing due to continuous transmission. Although it has various useful advantages, it has certain limitations too. In case of FDMA, we can see that it does not differ significantly from analog systems. That means the all the improvements of the capacity that depends on the signal to noise ratio in a major sense. That means the signal to interference reduction, we can say. And in that particular case, whatever be the flow rate per channel, so if I want to maximize that flow rate, there is a certain limitation, because maximum flow rate per channel is fixed and small. We have incorporated guard bands also so that we can minimize crosstalk, but these guard bands lead to a waste of capacity because it also needs some space, right? And hardware implies narrowband filters, which cannot be realized in VLSI, and therefore the cost is going to be high. So all these are about FDMA. Now moving towards the TDMA, the time division multiple access. What advantages, what extra advantages we can say, we can expect in case of TDMA, or what are the limitations of FDMA can be overcome when we are going to use TDMA. So we can see here that this IS-54, that standard specifies, traffic on digital voice channels. And you can see that sometimes what happens that whenever this TDMA is implemented, then in the initial phase of implementation, itself triples the calling capacity of AMPS systems. So it is a huge, advantages of TDMA on contrary of AMPS, we can say. But not only based on the calling capacity, we can say that this particular AMPS has a kind of, call capacity. If I have expected one or two times in case of AMPS, then we can see from the TDMA, the capacity improves by 6 to 15 times that of AMPS are possible. In case of TDMA also, we can see that the spectrum from 800 megahertz to 1900 megahertz, then we can see that many blocks under this particular spectrum are being used for TDMA. So we cannot have only AMPS which can use that high spectrum. We can have TDMA as well now. Apart from all these points, one major point is this: the transmissions, all the transmissions for this TDMA are digital. And in any case of TDMA and FDMA application, what happens that, this caller per radio carrier. So this particular, a kind of, a major performance matrix, which provides 3 times than the AMPS capacity. So basically, it is 6 callers on half rate, later, but in the beginning, that is the 7.3 callers, per radio carriers, it has been found for TDMA and or FDMA application. So which is quite, greater. It is almost, 3 times than what AMPS offered us. Since TDMA provides each call with a distinct time slot, so we have one major advantage, that several calls can occupy one single band. So whenever each caller is assigned a specific time slot, what happens that in some cellular systems, digital packets of information are sent during each time slot, and you know these all these packets are reassembled by the receiving equipments into the original voice components. So then we can expect lesser amount of loss. And obviously, as we have already mentioned in the previous slide that it uses the same kind of frequency band. So obviously the same kind of channel allocations must be there as AMPS. So we cannot lose any, advantages of AMPS here also. We can also avail those advantages as well with the new ones. What are the new ones? Which we have also, mentioned that it provides 3 to 6 time channels in the same bandwidth as a single AMPS channel can offer us. And these digital systems, can compress the spectrum which is used to transmit voice information by compressing idle time, so that is there if there is any kind of redundancy of normal speech, so that is also getting compressed. So in this manner, this digital standard has, we can see the 30 kilohertz bandwidth what AMPS also has. Now, after TDMA, there is a kind of extension which we often term it as extended TDMA, where this particular multiple access scheme claims a capacity of 15 times that of any analog cellular systems offer, and the capacity is also achieved by compressing quite time during conversation. So it is an extended feature of TDMA, because TDMA itself is having a kind of compressing features. So it is an extended feature. It is an additional one on that particular feature, and it can divide the finite number of cellular frequencies into more time slots than TDMA. So it is also one extended feature what we didn't have in the TDMA. So we can expect um, a kind of system which can support more simultaneous cellular calls than what the system can handle in case of TDM. Apart from all these advantages, TDMA also has certain limitations. If I go through CDMA, that is the code division multiple access, which is the next topic of today's class, we can see that there is higher synchronization overhead than CDMA in case of TDMA. And since we have this kind of advanced equalization process, so this advanced equalization is necessary for high data rates. Since the data rate is very, very high, we are saying in case of TDMA. Cell breathing process. This is a process that means by which we can borrow resources from adjacent cells. So this process is more complicated than what we can experience in CDMA. There is a slot allocation technique. Time slot has been given or allotted to a specific call. So in this manner, frequency and slot allocation process is also a little bit complex. And pulsating power envelope interface with other devices. So these are the key disadvantages we can say for TDMA process. When we move forward to CDMA, so this is also a digital air interface standard, which is IS 95 standard, which claims that it has a capacity which is 8 to 15 times what we have the capacity of any analog system. So it employs a commercial adaptation of military spectrum single sideband technology. So it is a different technology which comes into the picture, and it is found that it is essentially the same as landline service. So what happens here, that we can only has a certain kind of difference uh, from the landline service is what, that it access local exchange carrier, and that particular access to the local exchange carrier is provided via wireless phone. In case of landline service, there is no that kind of such phenomenon. In case of code division multiple access, as its name suggests, users are isolated by code. This is a specific one, this is a unique code. Therefore, it can share the same carrier frequency, so it can eliminate the frequency reuse problem. And every CDMA cell site, we can see that it can use the same 1.25 megahertz band. So with respect to the clusters, n equal to 1. So we can say that it simplifies the frequency planning in a fully CDMA environment, which we experienced a lot more complicated when we have dealt with TDMA scheme. This CDMA has a soft capacity limit because it is an interference limited system. So however, each user is a noise source on the shared channel, and the noise contributed by users are getting accumulated. So it is one limitation of CDMA. And if you can see that whenever we are going to use this CDMA process, it creates a practical limit to how many users a system will sustain. So mobiles that transmit excessive power increase interference to other mobiles. These are the problems that CDMA scheme will face. Apart from these, we can see that there is a kind of precise power control for every mobile, and that particular power control is getting critical whenever we are going to maximize the system's capacity and whenever we are going to increase the battery life of the mobile. So what happens then, we need to keep each mobile at the absolute minimum power level, which is the minimum necessary power to ensure acceptable service quality only. So ideally what happens, the power received at the base station from each mobile should be the same, so that we can have minimum signal to interference. So these are the points which we need to address whenever we are going to use CDMA. Now coming to the pagers, we are accustomed with this particular term, but maybe some of us don't know that this is a very small handheld device which has been released so that we can send brief messages to any subscriber. And whenever these messages are being sent, those messages can be of three types. Of four types. One is tone only, another is numeric. Numeric and alphanumeric, I love to be called as a one type, but no problem. We can segregate, or we can differentiate any alphanumeric character from the numeric ones. So basically, We have one type as tone only. We have the second type as numeric. We can have the third type as alphanumeric, and obviously the last one is a two-way. Now what happens that the initial pagers, which is the tone only pagers, those were used by military to send tones to alert soldiers only, right? So it is only, a one-way communication, Then when numeric and alphanumeric pages have been released, we can see that those pages can receive numeric digits and alphanumeric messages respectively. You can see in the pictures as well. This is one pager from Motorola, and this is one pagers from Unication. So, and you can see that the year is around 2008. So basically, those are the era of pagers, we can see. Now, this is since this is a particular pagers are used to send all these military, all these tones to alert the militaries, and we can expect that these one-way pagers which are used for only tone, for tone only pages, which can act as a tone only pagers, those pagers can only receive messages, right? So what happens that whenever we are going to receive this numeric digit and alphanumeric message, we can see that most widely used paging systems are this numeric and alphanumeric pagers. Now, response pagers are the two-way pagers. That means it can acknowledge, it can reply to, and it can originate messages using an internal transmitters. So that means two-way pagers are the most intelligent one. And pagers operate as a part of a paging system where we can expect one or more fixed transmitters, where I would like to mention that in case of two-way pagers, one or more base stations as well, and also a number of pagers carried by mobile users. Now, if you go through this particular picture, then you can see that it consists of a network of telephone lines. Those are the reception office, upstairs office or downstairs office. Then we have one base station transmitters, and in between these two, we have some telephone paging interference. Now, what happens that usually paging systems are typically used to notify a subscriber of the need to call a particular telephone number. So what happens in modern paging system, all those news headlines or stock quotations or faxes can be sent through pagers. So a message is sent to a paging subscriber via the paging control center. So this telephone paging interference, and along with the amplifier, this is the paging control center, and messages can be sent from either landlines, which is here the reception office or upstairs office or downstairs office, or an user can use the mobile phones as well. Whatever be the issued message, that is called a page for a paging system or for a pager. And the paging system, transmits the message, throughout this particular service area using the base stations. So base stations means we have some zones here. Let's say zone 1, zone 2, zone 3, and we have some loudspeakers which need to be, which need to radiate. So what happens that using these loudspeakers associated with the base stations, those loudspeakers, broadcast that page through the radio waves. So a wide area paging system may also sometimes, use satellite links for worldwide coverage. So this is all about paging system where we can observe that how a particular pagers work. Coming to the next segment, which is called General Packet Radio Service or GPRS. This is the last final module of today's class where we can see this particular, picture where we can see that, this GPRS system is usually a third generation system, and it is a particular step we can say that it is a step toward internet access. So what happens, and if you can see here that this is some mobile station which is connecting with the BTS. These are BSCs, MSCs, GSM or GPRS register, you can see. So those, GPRS with this IP address and IP router, these are some kind of, internet access is aiming for. Now what happens that this GPRS is also known as Global System Mobile Communications Internet Protocol, that is GSM IP, as it keeps the users of this system online. It allows to make voice call. It allows the users to access internet on the go. So what happens that whenever we can see TDMA process or TDMA scheme, we can now understand that even this TDMA users, get benefit from this particular system as it provides packet radio access. Now, this packet radio principle is employed by GPRS to transport user data packets, in a structured way between the GSM mobile stations and external packet data networks. So what happens that these packets, can be directly routed to the packet switch networks from the GPRS mobile stations. So if this is the process, then what are the salient features of this particular system? These three are the following key features, we can say, which this particular GPRS holds. That is the always online feature. That means this particular system, removes the dial-up process. So it makes applications only one click away. So every time you can be online. So you can access the internet. So that is the thing. It is an upgrade to existing systems. Why? Because operators do not have to replace their equipment. Rather, GPRS is added on the top of the existing infrastructure. And it is also the, integrated part of the 3G system, because GPRS is the packet data core network for 3G systems like H and WCDMA. Now, what are the then benefits of this GPRS? Firstly, higher data rate. That means GPRS can benefit its users in many ways, One of which is obviously this higher data rates in terms of shorter access time. Why? Because in the typical GSM mobile, Setup alone is a lengthy process, and equally rates for data permission are restrained to a kind of bit per second, let's say 9.6 k bits per second. So what happens that the session establishment time offered while GPRS is in practice is lower than 1 second, and ISDN line data rates are up to you know very high, like 10 kilobyte per second. So what happens that mm, in case of this high data rate and uh, this shorter access time also enables the third benefit of the GPRS, which is easy billing. Why? Because GPRS packet transmission, offers a more user-friendly billing than that offered by any kind of circuit switch service. Because in case of circuit switch service, billing is based on the duration of the connection. As we all know that this is very much unsuitable for applications with bursty traffic. Why? Because the user must pay for the entire airtime, even for idle periods when no packets are sent. For example, when the user reads a web page, but it is not any kind of downloading or uploading a kind of situation. So users also need to pay for that particular airtime as well. But here, on the contrary, with the GPRS, what happens that billing can be based on the amount of transmitted data. So the advantage for the user is that he or she can be online over a longer period of time, but will be billed based on the transmitted data volume. So this is quite a great advantage of GPRS. On this note, I would like to end today's class. I hope all the topics are very much understood by you. And if you have any queries, you can ask me personally.